let's keep talking about enantiomers, because I know that you probably right now feel like, oh my gosh, this is overwhelming. This is way too hard. But stick with me. It's going to clear itself up pretty soon. What we're going to talk about next are chirality centers. So let's look back where we left off. So the last thing that we were looking at here was stereoisomers in general. Stereoisomers can be either cis and trans, or they can be enantiomers, which are mirror images of each other. So if we have a double bond in the molecule, stereoisomers are cis-trans, and we know that cis and trans isomers are possible when we have a carbon-carbon double bond in the molecule. So when we see a structure that has a carbon-carbon double bond in it, then we're like, oh hey, maybe that's a cis molecule, or maybe that's a trans molecule. Let's see if we can identify it. What about enantiomers, the mirror images? In this section, what we're going to learn is how to recognize, how do I know if a molecule has an enantiomer. And as a reminder, an enantiomer means a mirror image that is different from the original molecule. So in this section, what we're going to learn is how to identify whether or not a molecule has an enantiomer. And the thing that we're going to look for when we're trying to identify enantiomers is something called a chirality center. Unfortunately, chirality center goes by a lot of different names. So they're also called chiral carbons. They're also called stereo centers. If I think of any more names, I'm going to add it to the list. So all three of those, stereo center, chiral carbon, chirality center, all mean the same thing, and they are a carbon atom that has 4 single bonds. It can't have any double bonds or triple bonds. And those 4 single bonds are to 4 completely different atoms or groups of atoms. So it's a carbon atom that has 4 totally unique things on it. If a molecule has a chirality center, this causes the molecule to be chiral, which means that it will have an enantiomer. Enantiomer or mirror image. So let's draw a picture of a molecule that has a chirality center. We're going to make a carbon, we'll put a hydrogen on it, we'll put a bromine on it, we'll put a chlorine on it, we'll put a fluorine on it. That's a carbon atom that has 4 single bonds, and those single bonds are to 4 different things: a hydrogen, a bromine, a chlorine, and a fluorine. So that is a chirality center, or a chiral carbon, or a stereo center. Let's look at something, a carbon that's not a chirality center. A carbon with a hydrogen, a bromine, and a chlorine. Because it has 2 hydrogens, That carbon is not a chirality center because it has 2 bonds to hydrogen atoms. It has bonds to 2 identical atoms, which means that it's not a chirality center. And so what does that mean in terms of stereoisomers? So the molecule with the chirality center, this molecule will have a mirror image, mirror, no, that's not the best way to say that. I want to say that differently. What I want to say, a simpler way to say it, that this molecule will be different. It will not be the same as its mirror image. It will be different than its mirror image. Because of its chirality center. The other molecule, because it does not have a chirality center, it will be identical to its mirror image. When we have a molecule that has a chirality center in it, it is useful for us and normal for us to draw that molecule using the wedge and dash bonds that I showed you in the last video. In this wedge bond that looks like a triangle, we're using that type of bond to indicate that that atom, in this case the chlorine, is sticking up at us. And the bond that's on the dash, the bromine, we're using that dash to indicate that that bond is sticking down. So if we were to look at this molecule, the straight bonds, the fluorine, the bond to fluorine, and the bond to hydrogen, those bonds would be flat against the paper. The chlorine would be sticking up out of the paper, and the bromine would be sticking down into the paper. If we want to draw the mirror image of that molecule, or the enantiomer of that molecule, we have 2 different ways that we could go about doing that. We could literally, I'm going to redraw it so it's a little bit cleaner. We could literally draw the mirror image like left hand, right hand. So here I've redrawn the molecule. If we want to draw its mirror image, we're just going to draw it backwards like that. And that, to me, this is usually the easiest way to draw the mirror image of a molecule. Another way that we can draw the molecule's mirror image is just to simply swap the wedge bond for a dash bond and the dash bond for a wedge bond. You can use either of these 2 techniques, whichever one is the most intuitive to you. So for this method, when we're drawing a mirror image, we literally draw the mirror image. We reverse the position. Everything that's on the left moves to the right. Everything that's on the right moves to the left. And the atom that are connected by the wedge bond stays wedge. and the dash bond stays dash. By that I mean the bromine that is connected by the dash bond stays connected by the dash bond, and the chlorine connected by the wedge stays connected by the dash. But everything that is on the left-hand side has moved to the right-hand side and vice versa. For your other option, the other way to do this, in this method right here, you're going to leave all the atoms in the same position. So whatever is on the left-hand side stays on the left-hand side, and whatever's on the right-hand side stays on the right-hand side. You are going to change the wedge to a dash and change the dash to a wedge. Now I know this is extremely overwhelming stuff. So maybe I'm gonna draw not a sad face, but like a I don't think I like this anymore face. But what we're gonna do now is move on to a worksheet where we're gonna practice a lot of problems, and hopefully that's gonna clear this up for you.